element that you need check periodically, minimum once per year in a boat. The galvanic isolator. You need check the galvanic isolator minimum once per year. Where is located normally the galvanic isolator in a boat? It's pretty close to the outlet where the shore power is connected. It's pretty close. The ground of that outlet coming from the pedestal enter here, and the ground continue into the bonding conductor, and the bonding conductor finish in the sink. Okay, I cut this grounding conductor, and I install the galvanic isolator. The capacity of the galvanic isolator is in amps. This capacity is according with what? With the capacity of the main breaker in my AC panel. What is the function of this galvanic isolator in a typical boat? Prevent that bad currents. Where is connected this element outside? To the pedestal and the building of that marina. If that building, the ground in that building outside is not good, is affected with currents, those currents enter in my boat and affect the bonding of my boat and accelerate the corrosion. Oh, I am going to install that filter. That filter block the intrusion of bad currents through the ground. What is the function of the galvanic isolator? Block the intrusion of bad currents in my boat through the ground. Simple.
And you check it with the multimeter and
correct
mode?
You remove this in both sides, you discharge with a cable, and you check with the multimeter in what function? Diodes. And you check in this direction, and the voltage should be going from
0.
You remember that video? 0, 0, 1, 0, 3, 0, 4, 0, 9, 0, 9 point something. Okay, and now you discharge again and check in the opposite direction. 0, 1, 0, 2, 0, 3, 0, 4, 0, 9, 9.7. Okay? Excuse me, what happened if when I discharge the galvanic isolator, the reading immediately is 0.9?
Bad.
It's bad. What happened if when I connect my voltmeter in diodes, the reading is 0 and it stays 0?
It's bad.
Bad. Yeah? The reading should be gradually increasing. Good? If my galvanic isolator is damaged, indicate what? Indicate that one day that element works, protect my boat, and was damaged. For me, I love it when I found it, my galvanic isolator damaged, because my galvanic isolator protect my boat one day. I don't know, probably in the past storm, no? In the past hurricane season, my galvanic isolator works. This is why you need check the galvanic, especially after the hurricane seasons, tornadoes, something like this. Check the galvanic isolator. This is the recommendation. Some people, instead of those 3 breakers, one breaker for shore power, other for inverter, other for generator, some people prefer this, the switch selector, inverter, shore power. Okay, no problem. This is nice. Some boats are coming with breakers, some boats are coming with this. Both of them are acceptable. You have one input for shore power, other for inverter, other for generator, and this is the output. Perfect. Okay, good. And this one is nice because in each source of power, you have one light for reverse polarity and other to indicate power in each one. This is good because I know if in each input I have reverse polarity. If the cables are coming back. Good, guys. You remember in the previous class of DC current, we learned the process to read amps in the DC panel. You remember that, no? With the ammeter, where you read the amps normally in a DC panel easily with the ammeter. What is the process? You remember? The process is you pass, normally this is the connection, voltage and common. You pass here for amps, and now you have the option to read amps. And you go into the breaker that you want to know what is the consumption of that equipment. Remember that the limit of those equipments is 10 amps. Okay? In the breaker, with the breaker on or the breaker off?
Off.
Off. The breaker off, the contacts are open. And you close the contact with this and you read the amps. You remember that I explained with details. This is for DC. In AC, to read amps, the clamp. Look at this. This clamp is nice. That clamp have the ability in between 4 amps and 80 amps.
So much more.
80 amps. That's good.
Yeah.
That's good. And you can read 80 amps in AC. Okay, guys. Look at this. I want to know in this particular board how much is the input. In this moment, everything is up. I am going to check the amps. Okay, and I am going to check the consumption in amps here. .1 amps. 11.2, 11.1. I love it. I love it, the clamp, because you go into the hotline that you wanted, and you know, we are going to turn on the lights, for example, here. 10.7, 10.8 amps, the consumption of this light bulb. Good, no? It's simple in the hotline. It's not complicated. Okay, don't forget, you need the clamp. You need the clamp to check the consumption. In what other situation in a boat is very, very, very important, the clamp? Give me an example. Pay attention, it's simple. When I turn on the water heater, immediately the breaker of the water heater pops.
Okay.
How you troubleshoot that problem? Pay attention. The water heater is off. The breaker for the overheater, the water heater is off. I go to the hotline. It is 240, have 2 hotlines. No? I check in hotline number 1, the black one, and I turn on the breaker. And look at this. The breaker for that water heater is 20 amps. When I hook at this and I turn on the breaker, the reading immediately is 37 and the breaker pops. Indicate what?
Short.
You have a short in the water heater.
Yeah.
You have a short in the water heater. Let me check the other hotline because it's double phase. When I turn on the breaker, is 12 amps. In the phase 1, in the winding internally, you have a short. The problem is the water heater. No, the breaker is small. No. Because that's the breaker recommended. Because if you check the label of the water heater, the consumption is 15 amps. For that reason, they put 20 amps breaker. You understand?
Yeah.
This is great. The same with the air condition. Oh, the air condition of the saloon. As soon as I turn on the breaker, 5 minutes later, the breaker pops. Okay, let me check. Let me put the hot in the distributor panel of the air condition in the hotline, and I start the air condition, and I check the amps. It's 7 amps, 7, 6, 7. The air condition is running, and suddenly go to 40, and the breaker. Yeah, it's a problem in the compressor. It's an internal problem over there. But with this, I verify that situation. Breaker that suddenly pops. With this. The voltmeter is only to indicate what is the voltage of my panel right now. That's it. Okay, guys, one thing. Suppose that I have a boat with double phase, and I have 2 ammeters. One ammeter for phase 1 and other ammeter for phase 2. Why is good idea install 2 ammeters? It's good because you know if the loads, the consumption in both phases is is pretty similar. Why is important know the consumption in amps of the phases? Okay, you need verify when you activate when you activate the breaker of the air conditioner of the saloon, what is the consumption in the phases? Oh, pay attention. In this moment is 40 and 35 amps. 40 in phase 1 and 35 in the second one. When I activate the air conditioner of the saloon, go to 60, 65 in the second phase and 30 in the first one. That's too much unbalanced. Probably that air condition is pretty close to be broken. You need to go to that air condition and check the consumption in amps in each phase with this. That's okay?
Mm-hmm.
And for today, don't use that air condition because you can damage the generator. The engineer in a boat should be
Listening,
yeah,
smelling.
listening, smelling, analyzing the boat, checking the gauge all the time, checking the gauge. Other important situation is this. I install 1 ammeter per each phase if I have double phase, or 3 phase, 3 ammeters. And a voltmeter exactly the same, 1 voltmeter per each phase. This is important. And other voltmeter in between both phases to indicate if I have 240. Pay attention. One day I see that in the panel 1 voltmeter is 190 volts and the other one is reading 50 volts, 40 volts. 190 in one and 30 volts in the other one. The neutral at the source of the power in the back end is loose or is broken, or in that terminal is open neutral. Open neutral. Oh, the same situation when I connect my short power, I have 190 in one phase and 30 in the other phase. The neutral at the pedestal is loose or broken, or non-neutral. If both phases are too low, 30 volts and 27 volts in the other phase, the power is coming from the generator. Where could be the problem?
Backend.
It's a problem with the backend. That reading is too low. It's 30 volts and 27. Can I adjust that difference with the regulator?
No.
This is a problem in the backend. I need check megometer, the winding. Excuse me. When the boat is running with generator, both phases, each phase is 150 volts. It's too high. In that particular case, the reading is 150, 150. Can I check a little with the voltage regulator before of that?
Yes.
Yes. Yes. I can check in the spot volts. I move it with the generator running with no load. I move it clockwise a little, the spot of voltage. Okay, 140, okay, a little more. 125, 125. Okay, let over there in 125 both of them and apply load
One at a time.
at the time. One per one. Okay, the voltage stay in 122, 123. That's correct. Let over there. You can adjust over there. Okay, what is the symptom when you overload the generator? When you apply excessive loads, what happens normally?
They drop and it take a long.
The generator try to accelerate, and suddenly stop. And the code producer is OL or OV, over voltage or overload. You remember in the display, indicate that one equipment suddenly is producing excessive load. Normally it's air conditions, or you have a problem in the back end and right now it's producing a lot of voltage. Okay, for a NEMA you have fresh all of those concepts. Don't forget the terminal resistors. Don't forget the amps, no more than 8 amps in the backbone. If the cables are mini or micro, if the cables are mid cables, 4 amps, no? no more than 50 devices in total, and no more than 6 meters in each drop line,
78 total.
78 in total, correct?
200.
You know those techniques. What happens if you have attenuation in the display? It's too much voltage drop. Alright? Don't forget that if the consumption of that equipment is more than 1 amp, you connect the equipment directly in the sub panel. In some cases, in some boats, the electronic sub panel is connected depend of the DC panel, the main DC panel. This is because in the main DC panel you have one breaker and the breaker side electronics. When you turn on that breaker, you bring power for that sub panel. Okay, how much should be the capacity of that breaker? That
Total of all the other panels.
correct, according with this. If not, it's not protecting
Yeah.
that. Okay. What equipments normally require external power? No from the backbone.
Autopilot, radar.
Autopilot, radar, the VHF radio,
VHF radio.
The actuator.
the actuators, yeah, all of those equipments here, no? And the rest, if the amount in lens is less than
20.
20 lens, you can connect directly here, no?